Alright, ladies and gentlemen, here we go. Week 5 of virtual learning, and go figure we're starting chapter 5. Where we are going to do some things that we have done before, but just more of it. Before, we have graphed these linear inequality, or linear equations, by using the y-intercept, which is 5. So I plot that. And then using the slope, and the slope here is -2. Anytime I have a whole number, I can just put that over 1. So my rise over my run is down 2 over 1. And I want you to always say right instead of over. So down 2, right 1. It's always down 2, right 1. It's always to the right unless you're going the opposite direction. Then I would go up 2, left 1. But I'm always going to go right. So let me just connect those here. And then I'm going to actually grab another color pen here. Hopefully I'm grabbing one that works. Okay, and I'm going to graph the other equation, okay, which you can see starts at -1 right here. Okay, and then I use my slope of 4. M equals 4 over 1, which means, again, up 1, 2, 3, 4, right 1, and there it is. Up 1, 2, 3, 4, right 1. I'm going to go down in the other direction, and when I connect those, what you'll see is what we're looking for here, which is the solution. Okay, the solution to a system, and a system just means more than one equation, right? So the solution here is that point right there, which is the point 1, 3, where they cross over 1, up 3. Now I can test this. I can test this to see if it works. Plug in, this is x and y. Plug it into x and y. So I got 3 equals -2 times 1 plus 5. And -2 plus 5 is 3. That works. I can test the other point, 3 equals 4 times 1 minus 1. Again, I'm plugging in x into the x, and I'm plugging in y into the y. And sure enough, 4 minus 1 is 3. It works. Okay? Then, when they get a little more complicated is when they're not solved for y. We have done this with the cover-up method, so you could say x equals 6 and y equals 6 and graph those. You could say y equals -9, but then x equals 4.5 gets a little nasty. So what we can do is solve these for y. If we solve them for y, we know the slope is next to x, and the y-intercept is a number by itself. So if I minus x to both sides here, again, past that, I get y equals 6 minus x. So 6 is my y-intercept, and right here, my slope is, well, if I put a 1 there, it's -1x. It's -1, excuse me. So I'm going to go to 6, 1, 2, 3, 4, 5, 6, and go down 1 over 1, and I've got a straight line there that's going to keep going down 1 over 1, so I'm just going to connect that. And then my other line, well, once I minus 2x here, I get -y equals 9 minus 2x, or -2x minus y if you want. And then I've got to divide everything by -1. So I'm going to have y equals, because I need y to be by itself, not negative, -9 plus 2x. I know -9 is my y-intercept way down here. And I know plus 2x means, again, 2 over 1. So up 2, right 1. Up 2, right 1, up 2, right 1, up 2, right 1, up 2, right. There's my point, right? And now I'm going to connect those dots. There's my point. That is over 1, 2, 3, 4, 5, and up 1, right? And I'm going to check it. This is x and this is y. 5 plus 1 is 6. That works. 2 times 5 is 10, minus the y value, which is 1. 10 minus 1 is 9. If they both work, there's my point right there. Okay, and that's what we are looking for here today, ladies and gentlemen. We're looking for intersection of points. Okay, so down at the bottom here, I would still solve this the same way. I would minus the 2x to both sides, and then I would get to here. Here I would minus the 3x to both sides. Once I do that, I get that -2 I have to divide by, just like I had to divide by a -1 up here. So I divided by -2, and this is just a fraction, 3 over 2, which just means up 3 over 2 to the right. So I'm going to start at this top one, plus 5, down 2, right 1. Okay, put that in here. It's a little bit more time consuming. Okay, but we'll get it. So I'm going to graph that in there. The other line started at -2 down here, and it went up 1, 2, 3, right 2. Oh, there's my intersection already. Right 2. I'm just going to get another point in there to be able to draw that in. There it is right there. 2, 1. Okay. Maybe pause it a second and see if you can do this last one, number 4, on your own. They're already set up in y equals form, and it's just a matter of graphing the y-intercept first and using your slope. And hopefully you can see that your slope here is 1 and your slope here is -1. So when you think of that, you would do that and you would do that in terms of your rise and run. Try it out, come back, check your answer. Alright, so -2 is right here. Up 1 over 1 is going to be there. I'm going to just draw a line on the diagonals. My other line starts at +4. 1, 2, 3, 4. And it has down 1, right 1, down 1, right 1, like that. You can see our point here. Right there is 3, 1. And again, I can check 3 minus 2 equals 1. -3 plus 4 equals 1. It works. Even on this one, -2 times 2 is -4 plus 5 is 1. And multiplying times a fraction, I won't even tell you. 1.5 times 2 is 3. Minus 2 does give me 1. It works. Okay. All right. So that's graphing. Now we're going to get on to, trying to solve by elimination or substitution. So what I'm going to do here is actually I'm going to start a new video. That is how we are going to just show you how to graph here. And then you can see on the homework, it is the first 3 problems here on the homework. That's what you have to do there. Okay, it's just graph those equations. And the only one you have to solve for y is this one. So if you at least try there, good enough. But you should be able to do A and B. Okay? Plot your y-intercept. Maybe we should write that. Plot y-intercept. That's the first step. Second step is use slope. So rise over run. And it's always the number next to x. So here I went down 2, right 1. Here I went up 3, right 2. Here I went up 1, right 1. Here I went down 1, right 1. It's always to the right. Okay? Alright, and so that will help you with that. Go check out the next video for the rest of the assignment. This is 5.1.